All right, algebra. We're going to work with functions of quadratics now, quadratic functions. That's why it says f of x up here, function of x. That's all we're doing right now, but it's quadratics because now we have an exponential value within the problem. I'm going to show you why I never really use 3 in these problems unless it's a beneficial one for me if it's a fraction. In this case, if I put a 3 in, all you're doing is taking the value of x, 3, putting it in for the x in all of these problems up here. Look at what happens with this when I place the 3 in for the x. It turns into 3 squared, which is 9, 4 times 3, which is 12, and bring down the 3. 9 and 12 make 21, 21 and 3 make 24. So my fine ordered pair that I'm going to graph over here is 3 and then 24 is what the answer is. So my ordered pair is 3, 24. My graph goes to 10. Okay, it'd be nice. I'd make it to maybe by 2s or something, 2, 4, 6, 8. But no, I don't want to make it this big. 2's bad enough. Okay, 2's going to be a bit of a pain in the butt as it is. But good gracious, I'm not going to use 3 in this case. Okay, forgot to make those negative. All right, so if I change this into the 2, 2 squared is 4. 4 plus 8 is 12. Plus 3 is 15. The ordered pair is 2, 15. Still ugly, but not hideous, not deadly. Okay, 1 getting a little bit better. 1 squared is 1, plus 4 is 5, plus 3 is 8. 1, 8. 0, 0 plus 0 plus 3. That's nice. 0, 3, easy one. Negative 1. Negative 1 times negative 1 is a positive 1. Minus 4 is negative 3. 3 plus 3 is 0. Ooh, interesting. Negative 1, 0. And negative 2. Negative 2 squared is 4. 4 times negative 2 is a negative 8. Plus 3, that makes negative 4 plus 3, negative 1. So your ordered pair is negative 2, negative 1. All right. Now, let's graph these suckers. On this graph right here, my handy-dandy graph, right on the back of this. I'm not going to do 324. 215 is still a pain in the butt. It's up here. I'm going to go with 1, 8. 1 over, up 8, right there. Right or left 0, up 3, right there. Left 1, up 0, right there. Then it's negative 2, positive 1, or negative 1, right there. Okay, this graph, if you look at it, is making a parabolic curve. Let's just test to see if I put a negative 3 in here, okay, where this graph goes, where the vertex is, and, well, don't worry about the vertex. If I put, let's make it a negative 4. Negative 4 squared is a positive 16. 4 times negative 4 is a negative 16 plus 3. 16 minus 16 is 0 plus 3. So negative 4, 3. Negative 4, 1, 2, 3, 4, positive 3. 1, 2, 3. Right? Oh, look at this. It looks like it's going to go right here. And it looks like this is our midway point right there. Okay? So when we graph this, all you're doing is plotting the points, and you're going to start to see the curve of the line, where it starts to break and where it turns back up. Maybe it's turning sideways, who knows? But this is called a parabolic curve, a parabola. There's a substantially easier way to figure this out, okay? Substantially easier way. If you can find this thing right here, which is called the line of symmetry. The line of symmetry, you know where your vertex is going to be, okay? And in this case, it's a minimum because it ends right here. It goes on forever up. So your maximums are unlimited. It can go on forever up, but your minimum is right there. It's going to go to that point. So your minimum is negative 1 on your graph. Your line of symmetry is negative 2. In this case, it's going to be right in there. Or you could say that your vertex is negative 2, negative 1. Your line of symmetry is at negative 2. Your y-intercept is at 3. Ooh, that looks familiar. Is 3. Okay, so we figured out all of this. If this crosses here, then you know right over here, it's got to be 1, 2 over, 1, 2 up over there. This one is 1, 2, 3 over, and up to here. So I go 1, 2, 3 over up to there. It should be right there as your parabolic curve. So it's consistent. All right. There's a simpler way to find all of these things. We're going to use this formula. F of x is equal to x squared plus 4x plus 3. Okay. I'm taking a walk. Axis of symmetry. To find your axis of symmetry, all you use is negative b over 2a. But what does that mean? We're working with parabolic curves and the exponential functions right now. Ax squared plus bx plus c, where your a, your b, and your c are all going to be used to find things for you. Now, with our original problem, x squared plus 4x plus 3, x squared plus 4x plus 3. So if I take this, this is my a. What number is in for a? That's a 1. What's the b? b is 4. c is 3. So if I'm going to find the axis of symmetry, I'm going to take b, which is 4, over 2 times a. 2 times 1. But it's a negative, whatever it is. So 4 divided by 2 is 2, but it's negative. So my axis of symmetry is negative 2. That's my axis of symmetry. Now I just take this negative 2 for the x and put it into my equation. So the negative 2 down here, 4 times negative 2, and the plus 3. Negative 2 squared is 4. 4 times negative 2 is negative 8, and a positive 3. 4 plus negative 8 is negative 4, plus 3 is a 1. So your vertex in this case is the ordered pair negative 2, 1. That means negative 2, 1 is our turning point, where your parabolic curve turns, because we know that the axis of symmetry is that vertical line that splits your graph in half. And the y-intercept is c. Well, c is 3, so my y-intercept is 3. All of these things are based on this formula. I didn't even need to graph this sucker over there. And I know now, if I was to just draw a basic little graph, I know that my vertex is negative 2, 1, back 2, up 1. Is it up 1? Or is it a negative 1? It should be negative 2, negative 1, sorry. Back 2, down 1. That's my vertex. My axis of symmetry is right here, and my y-intercept is c, which is 3. So I know it's boom, boom, boom right there. So I've got 2 points automatically. Guess what? 1, 2, up 3, over 2, up 3. I've got 3 points without having to do squat on this problem. And I know my parabolic curve should look like this. I now know that my axis of symmetry, my vertex, is all right there. And this point right here, that right there, is the vertex is a minimum because it's the lowest point of this graph. Guess what? All the same crap that I just did with this problem right here, everything that I did here with all this hideous graphing, all this garbage that I did in here, all of that stuff, I did with negative b over 2a, putting that answer in for the vertex x, finding what the y value is, and knowing that my y-intercept is c right here. I found all of that out just by using those points and parts right there. Makes your life a little easier. Okay? That is going to be what you're going to be doing next with quadratic functions on page 425 and beyond. Okay? So that's going to be helpful. I will talk to you guys later. I'm hoping this is helpful. I'll do another one again tomorrow with some other problems from the page that you're going to get. But that's quadratics that we're going to be working with. We're going to start working with the quadratic equations. So miss you guys. That's my hand waving. I'll talk to you soon. Bye.